So when you first enter the Automatika site, you're going to be presented with your login credentials. So go ahead and enter your email and your password. Go ahead and log in. And more than likely, I've already got a project here, you're going to be presented with the new project or open project dialog box. So here's all of your projects. We're going to pre-populate a couple projects here in your library, but you can always create some new ones. This is just simply opening the project. You can delete the project or you can rename the project. So you can come in here, for example, and rename it as text functions 2. Go ahead and confirm there. Going to go back into open project again. You can see it's renamed back to 2 now. So that's just your simple file menu for the most part. Up here in the other file menu, you've got the ability to create a new project. You can save as the marketplace and invite a friend. Those are not functional yet. Only admins can invite a friend. The marketplace is going to be a place where we can share code with others or manufacturers. For example, pneumatic manifold manufacturers, servo motor manufacturers, we can have them, or we can write blocks, custom blocks, kind of like add-on instructions. You'll be able to use those to help build out your programs. So the next part of the interface are tabs. This is actually a work in progress. So right now this is not going to work for you, but you've got your default tab. You can add more tabs and you'll be able to rename these. Tabs are going to be used as subroutines or functions to be able to divide up your program. So you'll be able to, for example, if there's a subroutine that you could call multiple times, you'll be able to put a subroutine in one of these tabs and call that subroutine. These tabs will be able to have properties like always running or only running when they're called, constantly looping, things like that. So it's just a way to divide up your program so you don't have to program all in this one space in here. But like we said, right now they're there as a placeholder. They're not quite functional yet. You look over here on the left side. This is the heart of the program right now. Of course, programming language. I've already got a program written here, which we'll go through in a minute. But these are all your toolboxes, and these provide all your tools like logic statements, if, then, do's. Not, true and false, for example, things like that. When you want to use a tool, you just drag it out into your window here, and now your tool's out here. If you want to collapse this back down again, just click back in here, and it collapses it down, otherwise it stays open. The tools, we'll build on these a little bit later, but if you ever see a plus, you can always just expand it out. So you can do an if, then, else, or you can take away the else commands. You can also click on a block, right click on it, and there's some commands here. Duplicate, comments. You can collapse a block. So for example, if you come over here and right click and collapse that block, that just takes it down so that it's still functional, but you don't have to look at all the code underneath it. You can also come back in here and expand that block back out again. Disable block basically just turns it as gray. It won't function. It's kind of like commenting out that block, right? Enable it back again. And of course, delete and some help, right? You can also use Control-C, Control-V, Control-X to copy and paste, okay? Or Control-X to delete and put it to your clipboard. And then we come back in here and paste again. All the other commands in here, you've got things like loops, repeating a number of times or a variable number of times, repeat whiles, counting, things like that. Text is text manipulation, of course, printing, taking uppercase, trimming spaces, concatenation, things like that. Here are your math functions, integers, reals, doing math operations, plus, minus, divide, to the power of, square roots, all your trig functions, modulus, remainders of, constraining numbers, random fractions. You can round up, round down, things like that. Check if something is even or odd, or if it's a prime or a positive or negative, things like that. So I'll use these different math functions. Lists are like arrays, so you can build multiple arrays. If you've got a lot of data, you can pull it all to these gigantic, arrays. Like for example here, let's go ahead and we'll create a list with more items. You can just kind of keep creating them. You can also do a loop and iterate. So you can create a list with items and then just concatenate, right? Keep adding to it with a loop. Variables are where you create your variables. These can be text, these can be numbers, these can be booleans. You just simply come in and say create a variable. It's going to ask you for a variable name, called variable 1, for example. And now you've got variable 1 in your list of variables over here. We'll talk about your variable list over here in a little bit. But using these commands, you can set variables to certain things. You can change them by an amount or change them by to something else. You can wait until a variable is equal to something. So as you're looping through, you're waiting for that variable to get to a number. So this might be in a subroutine where you're waiting for, once you've picked the 50th item, then this fires off. Blocking wait basically means that the program halts at that line until something happens. Okay. Time, you've got some simple things like wait in a number of milliseconds. You've got timers. You can start your timers. Again, creating timers. We created this timer number 1 in here. All right. Set timer 1 to be a countdown or a count up. You can read the timer. You can start the timer. You can stop the timer. So, and again, over here, your timers are over here. Functions, this is something that you're going to be able to call sub-functions. So basically you can come in here and create a function and then call that function. So once you create a function called function 1, for example, if you come back into functions, you'll have function 1. So I could pull this in here and say, hey, call function 1, which would then go and call all of this, right? What was inside of here. Functions right this second are not working because we are working on the tabs to be able to call some of these functions. So we kind of got like your guys' input, whether you'd like functions within this one tab or do you want these functions to be in these sub tabs. So that's something what we're going to need to discuss a little bit. Finally, probably the most important here is your GPIO. That stands for general purpose IO. Again, you can come in here and create, all your GPIO is over here already created. We'll get to that in a minute. You can set your whichever GPIO you want to use. Some of them were renamed. Some of them are still just the standard pinout numbers. You can get the amount. You can read it to see if it's true or false, on or off. You can do a wait until that IO changes, a blocking wait until it changes. Again, the program will halt there, or until it's changed state. So you really don't care whether it's on or off. It's just if it's changed state. So for example, like a push button, a momentary push button, when it changes state, that's when you'll continue on. So you don't have to look at whether it's on or off. So that's your commands over here. We are going to be adding some more as we go, fleshing them out. Changing them. If you find that one of them doesn't work the way you think it should work, or perhaps, for example, on this GPIO, we've already talked about set this to, we're actually going to have an extra command out here that says whether it's on or off automatically built in, right? So you don't have to pull in a true or a false and attach it to here, because pretty much IOs, always pretty much on or off. So that just talks about your tools over here. Next, we'll talk about the graphical window here. So this is your main coding window. This is kind of where all the real action happens. It's very simple. You just start pulling commands into here like we've already built. You've got connectors. You've got a left connector, sometimes a right connector, a top and a bottom connectors. You just start building your code like this. So for example, if something happens, whatever that is. So for example, we can just come in here and copy. If this red switch is on, then repeat 123 times whatever your code is in here, and you just start pulling in whatever commands that you want. A print statement, you can see that's a top connector. It'll go to a top connector. You see how that highlights, it says it'll snap in there. There you go. So if it's on, it's going to print your text 123 times until it's done, and then it's going to end the software, right, or end the program. You can pull these programs apart by pulling this out, putting that in there, pulling that out, throwing it back in there, for example. We come back into our larger one. If you grab here, it's going to pull everything below it out of that loop. Okay, so then we can snap it back into the loop. Oops, snap it back into the loop. If you pull this bottom one, it's only going to pull that last little bit out, right? So that's the only thing. You just got to make sure you pull from the lowest position that you want to remove. Okay. Within this, as we kind of talked about, a little bit before, you can right click on things, duplicate, collapse that block. So for example, there we go, we just collapsed that entire block, and it shows that there's actually code. This little line here shows there's code underneath it. So you can come in here and then expand that block back out. You can come in here, disable that block. So now that's commented out, but you still got the code, so you don't have to delete it. Go ahead and enable that block back. You do have a search here. So if I wanted to look for everything that's in green, you see everything kind of turned this darker gray color here that contains green. All my print statements, for example, I come in, oh, I don't have any print statements. Never mind. How about my weight statements? There we go. So there's a weight statement down in there. So the search box is just a nice little way to try to find some of your code. Over here, you've got a couple different tools. This is expand, full. This is center. You've got your plus, your minus. You can also use your scroll wheel to go in and out, and your garbage can, right? So if you have a block that you don't need anymore, you can delete it by right-clicking on it, or you can drag that block down to the garbage can and get rid of it. So the last thing is the backpack. That's just a place to store your code that you're going to use over and over again. So for example, we've got, turning on red switch, turns on the red light, turning off the red switch, turns off the red light. So we use this over and over again. So rather than rebuild that code, let's go ahead and copy it, paste. All right, so we got a little copy of that right here. Let's go ahead and pull it into the backpack. You can see now the backpack icon changed. We'll go ahead and delete this if we want. When we come in here, there's that code. So we can go ahead and pull this back out and just keep reusing it. So it's just kind of like a favorites, basically. You can store all of your code that you're going to use multiple times. Let's just say, for example, I'm going to use this weight statement a lot, for example. Let's go ahead and dump it in the backpack here. And you click here, and now I've got that weight statement in my backpack that I can pull out. So again, it's just a little shortcut to allow you to code a little bit faster. So that's the main coding window. Next, we'll talk about the variables and GPIO tab. So over here, we've got a couple different tabs. You've got your GPIO, which is all of your IO. When you start a new program, these are all going to start from GPIO 1 through 34, 28. These are the pin numbers. These are actually the GPIO numbers. Now, right now, this is set up for a particular device. When we get to the full hardware version, you'll have whichever device you have in here, which will tell you how many IO points you have, what type of IO points they are, whether analog or digital. So this will all be pre-populated. Right now, we're just being fairly generic. On your GPIO, if you come in and click on one of these, let's come down here, for example, you can rename this to test IO, for example. And now it's test IO. So if you come in here, now you'll have one called test IO. Right, so this is how you can quickly choose, which IO point that you're wanting to use. This is the state of that IO. So right now, this shows red is off, green is on. So by clicking on it, you can turn it on and off manually. This indicates whether it's an input or an output. Now, right now in the prototype, since we're emulating, we're pretty much treating them exactly the same. You can turn on and off inputs and outputs either way. In the real world with hardware, of course, the inputs you're not going to be able to turn on. You will be able to force them in debug mode, but ideally these are external inputs coming into the controller. But this is saying this is an output, and you do that, and it's saying it's an input, right? So be able to change these if they can go either way, or by choosing the configuration, they may be predetermined that they're all inputs or all outputs. Finally, you've got a D, and if you click on it, A, analog. So again, this could be an analog input or an analog output. So you'll be able to set this number. You can actually come in here right now and say, hey, it's 100. Okay. Right now, analog, we don't have functioning 100%. We're getting pretty close to it. But you'll be able to scale your analog inputs and outputs as well to be able to convert them from from a 4 to 20 to an integer or something like that. So right now, for the most part, we're keeping them all digital right now until we get the analog fixed. Lock button here. This tells you that the tab is locked, which means you can't come and change any of this, right? So in case you don't want to accidentally click on one of these and change it from an input to output, or you don't want to rename it accidentally, We do need to allow you to still change the state, which right now you can't, but that's just something we're working on. So then you can come back in here and unlock it, right? We may even add some password protection in there too. So once you write it, you can't have other people come in and change that. You've got a couple other tabs here too. Your variables, here's all your variables that you've created. We are going to add another column that shows the value and another column that shows the type, whether it's an integer, a Boolean, a real, things like that, or string. So right now, the way the software works, it doesn't really care what type of variable it is, which is good and bad. It's very flexible, but you also, if you try to round a text string, you're going to get an error, of course. So we're going to have some other columns here where you're able to define the type of variable and define the actual value. So if you want to come in and override the value of a variable, you can do that, or see what it is right, at any given time as you walk through the program. And then finally is timers. I have one timer set. Again, it'll probably have a column here saying what type of timer it is, count up, count down, and what the current value of that timer is. Maybe even a reset button here. Let's get your input on that. So that pretty much describes the tabs column over here. Final thing is we're just going to talk about how to run your programs. So the last little bit is we already talked about the file menu up here. Shared. This allows you to make the program public so that if you do this and then copy the URL of the program, you can actually send it to somebody else who's already signed up for Automatika, and they can look at your program if you need help, or if you found a bug, or just want to share the program with somebody. They're able to look at your program. This is the name of the program right now. It's called Lights. Okay, and then we've got a couple other buttons up here too. This hash button. What this does is it generates the Python code. So down here in this window, which you can also resize as much as you want, this shows you the Python code that is generated by all your graphical inputs. Okay, you don't need to do anything with this. You don't need to know Python. We will have another button here eventually that says download to controller. It'll download the controller, and then you're off to the races, right? We may allow some ability later on to do some of this editing of this code if you need to later on, but that's probably coming in a later version. Okay. Here is your play button. So this is going to execute the code. Right now, it executes the code, but there is no ability to step through the code or set breakpoints. That will be coming down the line as well, so that you can function step through the code, and you get to a breakpoint and you look at what your variables are, turn IO on and off. But for example, just right now, this is very simple. This is just, if my red switch is on, I click that, you can see my red light comes on. So there's my input, there's my output. If I turn my yellow switch on, my yellow light comes on. Turn my green switch on, my green light comes on. And then I've got a reset button. And when I hit a reset button, it turns all the switches off, and then which turns all the lights off, of course, right? So I can turn those two on, reset, reset, and then they all turn off, right? So that's just, that's this program. Shows you how to run this program. Very, very simple example of just, 3 switches, 3 lights, and reset button. If anytime you want to stop the code, you hit the red stop button and it's aborted, right? And you can always, again, just close this window down if you don't need it. So that kind of walks you through some of the basics. I think that hopefully you guys can find some other interesting uses and some use cases, and try to break it and tell us what else that we need, to be able to accomplish your automation projects. So hopefully that's useful for you, and please let us know if you have any questions. Thanks.